Hi everyone, welcome to the next session of SAP HANA online training tutorials. So in the last session, I have explained what is analytic view and what are the steps we have to follow to create an analytic view and how to create an analytic view in HANA system. So what we have seen in the last session is basically how to add a transaction table into an analytic view, and then how we can join different dimensions or nothing but different attribute views to an analytic view. So basically we have seen how we can join more than one table in an analytic view, but where we can apply the business logic. So when we say business logic, a business logic is not going to be just joining tables. Business logic will be applying filters or calculating new columns or calculating new measures, uh, um, configuring different aggregations. So or having input parameters, user-based input parameters. So these are all the different types of business logics we might get from customers. So where we can do all those things. So these are the things I'm going to explain as part of this session. So that's where I'm going to call this as the advanced options we have in analytic view, which is helpful to apply a business logic or business transformations. So some of the business transformations or logic you get is like applying filters on transaction table. Let's say I want to see only last 2 years of transactional data in the reports, or I want to see only last 5 years of transaction data in the report, or I want to see only this particular country's sales data in the reports. So filters, one of the transformation or one of the logic we might need to apply is filters. And the next thing is like calculations, calculating new columns. So it can be attributes or it can be measures, calculated columns. So the calculated column can be an attribute or it can be a measure. And then the next transformation or the next logic we might get is like identifying restricted attributes or restricted measures, sorry. So what is this restricted measure is like, basically you want to compare your sales revenue year by year. Like you want to have 2008 sales revenue in one column and then 2009 sales revenue in another column by customer or by product, so that you can easily compare those values. So how can we achieve those things? So most of such kind of things can be achieved with the help of restricted measures, or calculating measures with different aggregations. So basically the default aggregation what we saw was like summation, but how can I mean what I need to do if I need max of my measure or min of my measure or count of my measure, or distinct count of my measure. So what we can do to achieve these things. And the other kind of transformation you might get from a business is like, how can I apply input parameters? So these are the different types of transformations we might need to apply at enterprise level to get the proper data out for reporting. So now we'll see how we can apply all these in analytic view. So first, as a first step, let's look at how to apply filters in an analytic view. Okay, so let's get into our system. It takes few seconds. to get in. So now we have got our analytic view here, which is AN_sales. And as I already explained, we have three different layouts. One is data foundation, the next one is star join or logical join, and the last one is semantics. So now where we can apply filters, let's say we want to apply filters on my transaction table. Okay, so if I have to apply filters on my transaction table, I can go to data foundation, and then let's say I want to apply filter on my shop ID, where I want to show only a few shop IDs sales orders in the output. So what I can do is I can right click on my shop ID and then say apply filters. So here what we can do is we have different set of parameters, which one based on our condition you can apply whatever suits for you, and then you can see the distinct values you have for that. Okay, so then based on that you can choose. Let's say suppose I have some shop IDs 3 and 64, and the remaining all shop IDs are more than 100. So I want to show the sales data for the shop IDs with value more than 100. So what I can do is I can quickly choose greater than, and then I can go ahead and enter value 100. So now let's say before applying any filter, if I see the data, and if we go to distinct values here, let's search for shop ID. So we have got total 13 distinct shop IDs, and out of which we have only 2 shop IDs with less than 100 value. So now let's go ahead and put that as a filter here. Apply filter and greater than, and I'm going to use value 100 here. Click on OK. Now we can quickly see there is a filter symbol beside shop ID, which means there is some filter applied on that. Now let's go ahead and activate this. We can see it's running here and then completed successfully. Now if we go ahead and do a data preview and then distinct values, again search for shop ID, then shop ID, we can see only 11 distinct values. So earlier it was 13 distinct values, now we can see 11, and we don't see 3 and 64. So this is how you can apply filters on any column from the data foundation. Okay, so how can I apply filters on attribute views? So you cannot apply filters on attribute views in logical join. So if you want to apply any filters, you have to go to attribute view and then apply that filter, then activate that, so that by default it applies wherever you use that attribute view. It can be a part of analytic view or it can be part of a calculation view. So wherever you use that attribute view, the same filters you applied at attribute view level will be applicable to all those objects. But you cannot apply filters for attribute views in an analytic view. That's the reason even if you see here, you won't be having an option to apply filters here. Okay, so that is about applying filters for the transaction table we chose in a data foundation. Now the next one is like, how can we create additional columns? It can be attribute or it can be a measure. So that was our next one. Okay, so how we can apply, how we can create additional columns, which means calculated columns. So now to create a calculated column, what we can do is here if you see in the star join or logical join, we have different options here, and one of the option is calculated columns. So to create a calculated column, right click on calculated columns and then say a new calculated column. Okay, so here you can give your calculation column name. Let's say I want to give column name as discount. Okay, because I have, if we look at our measures, what we have here, I have my margin, and then I have what was the total amount I've sold. So now, and we also have sales price. So for each article, we also have sales price in our article uh, dimension. So if we close this, if we look at our article dimension, we also have sales price. What is the sale price of each article? So to identify discount, like how much discount we have given, what we can do is how much quantity we have sold. So it's going to be like this. So what was the quantity we sold into what is the sale price of that particular product minus what is the amount I have got from that sales order. So the difference between these two is going to be the discount I have given to that particular customer. So to identify that, what we can do is, let's go ahead and create a new column, calculated column, and let's name it as discount. And here we have to select what is the data type. So I'm going to make this as decimal, and then length 2, then precision or scale as length 10, and then precision or scale as 2. Now the next one you have here is column type. So what is this calculated column going to be? Is it an attribute or is it a measure? So right now we are calculating discount, which is going to be our measure. Okay, if you are applying some calculations on your attributes, then it is going to be attribute. But right now we are calculating discount, which is on our measurable values. So we are going to make this as measure. Okay, and then there is other option here, aggregation type, and you have two more additional checkboxes here. So by default your aggregation type is going to be formula, which means when you run any query on this, based on the attributes you select, it will calculate this, it will apply this calculation on the fly. But if you want to calculate this before you do the aggregation, like before you add the attributes, you can choose calculate before aggregation, and then you can choose what is the aggregation type you want. Okay, so by default, if you don't select this, the aggregation type is going to be sum. If you want a different aggregation, then you have to select calculate before aggregation, and you can choose what type of aggregation you want. But right now we need just a sum, that's why we are going with a formula. Okay, now how to write that formula here? So we have all the columns here, and ours is going to be the quantity sold, which we have here, into multiplied by sale price, and we have sale price in article. Sale price, put this in brackets, minus amount sold. So amount sold, and we can validate this syntax. So it's valid. Now we can go ahead and click on OK, and then now we got our additional calculated column here. Let's go ahead and activate this. It's completed successfully. Now let's go and see the data preview. Let's go to the raw data here, and let's bring the sale price as well near to this, so that we can quickly compare whether our calculation is correct or not. Okay, so this is coming from 80 article color, but we need the one that is coming from 80 article. So here we have sale price. Okay, so let's bring this to the end. So if you want to shuffle the column sequence, just click that and then drag it so wherever you want. So I'm gonna take this to the end. Okay, so now we have got this here. So the sale price is 149 and the quantity sold was 1, which is going to be same, minus the amount sold. So the actual price was 149, close to 150, but the the particular product was sold at 170, which means we didn't give any discount, but additionally the extra price was kept on this, which is 20. But if you look at the second one, the sale price is around 114, but the product was sold at 20, which means around $95 discount. So which means our calculation is working fine. So this is how we can create a calculated measures. So now let's see how we can create another one. So let's say we want to identify, and now like we have what is the total amount of that order, but let's say we sold around 5 quantity. Now we want to see at how much rate each unit was sold. Okay, so obviously the calculation is going to be total amount by quantity. Okay, so we have to apply that condition. Now let's see how we can create that. New calculated column. So let's give the name as sold at unit price. Okay, and again make the data type as decimal, then length 10, scale 2, make this as measure. So here condition is going to be amount sold divided by quantity sold. Then we can validate the syntax. Click on OK. Now we have got additional one. Then it's activated successfully. Now let's go ahead and see the data preview. Let's go to raw data. So here we have got an error. Why? Because there will be scenarios where the quantity sold is 0. Let's say you have got some returns from the customer. The customer has returned some product. So in such cases, the quantity sold will be a 0 because you have got that return. If quantity sold is 0, then this value will become infinity, something by 0, which is invalid. So that's why we have got that error. So to handle that, what we have to do is, let's add an if condition. If quantity sold is 0, then the unit price is going to be 0. Else, apply this condition. Okay. Now let's go ahead and validate the syntax. So it's valid. Okay. Activate again. Running, and it's completed successfully. Now let's go ahead and do the data preview. So overflow in a numeric calculation. Okay, so let's go ahead and change the length, increase the length, and then see how it goes. There might be some big values in that. So it's active now. Go here, raw data. So it's still giving same error. So let's see, before that what we do is, let's see what are the values they have. Go ahead and activate this without a new calculated measure. Raw data working fine. Now let's look at our measures. Quantity sold doesn't have much values. There's only 8,400. Let's add that again and see. So let's make this as actual unit price. Put this as decimal 20,4. Then measure. Then the condition is going to be if the quantity sold is 0, then 0, else it's going to be amount sold by divided by quantity sold. Let's validate this. It's valid. Okay, activated successfully. Okay, now it's working fine. So now we can see this additional one. So yep, see here, the amount sold was 995 and the actual unit price, so based on the amount, is 165.833. Now let's go ahead and see what is the sale price of that unit. So if we see the sale price, it's 255. So which means on each item we have given around $70 discount. So this is how we can create additional calculated measures if we need based on the business requirement. So in the same way, you can also create calculated columns as well. So calculated attributes basically. So we have seen how to create calculated measures, but in the same way you can also create a calculated attributes. So one of the scenario may be like, we have shop ID and shop name. So few people might need something like, they need shop name, and just beside that they also need what is the shop ID, because some people will just identify by shop ID, but someone might need shop name as well. So in such cases, what we can do is we can go ahead and create a new calculated column, and then you can name it as shop ID underscore name. And then we can make the data type as nvarchar, then length as 200. Now the column type is going to be attribute, because we are trying to create an additional attribute here. So the logic is going to be, we have shop ID and shop name, and we need shop name first. Then we are going to use concatenation. So I just want to put my shop ID in open close parenthesis. I'm going to use like this. Can validate this. Okay, let's see what's the error. Okay, shop ID is integer, so we have to use conversion function for that. So what we do is we'll use string of. Okay, so let's go ahead and use string of function for this. Okay, now go ahead and validate. It's valid. Then click on OK. Activate. So it's completed successfully. Now let's go ahead and see the data preview. Raw data. See, now we have got shop name and then what is the shop ID. So when you actually take this column for the report, so basically along with just showing your shop name, you're also showing what is the shop ID. So for this kind of scenarios, you can make use of a calculated column option what we have here. Now let's look at the second requirement what I explained. Let's say, instead of looking at their revenue by, instead of just looking like this, what is the amount by shop name, they want to see what is the amount in 2009 and then what is the amount in 2008 and then what is the amount in 2007. So basically what we have to do here is like you need to restrict your revenue by calendar year so that you get it in different columns. If you get it like this, it's very easy to compare like how your individual shops are performing over the time and in which year they have got more revenue and in which year they have got less revenue, something like that. So how can we achieve this? Most of the times with traditional databases, we used to apply all these logics at a reporting level. But with HANA comes into picture, we can do all these things at HANA level itself so that there will be less burden on your reporting clients. So now let's see how we can do this. So actually this type of requirement can be easily achieved with the help of restricted measures option we have in Analytic View. So now let's see. So in the same way, like we have amount sold and we also have our time dimension here. So now let's create new columns by restricting amount based on years. Okay, so what we can do is so before we do create that, let's go ahead and see for what years we have revenue. So for that what we can do is let's search for year, add it in label, and then search for amount sold, add it in y-axis. So we have got revenue for 2004, 2005, 2006. So what we can do is now let's go ahead and add a new restricted column here. So right click on your restricted columns folder, say new, and then amount 2004. So what is going to be your measure here? Measure is going to be amount and what restriction you want to apply. So that we can add here. And if you want to add some expression, complex expression. So basically, like if it is going to be straight filter on one column, then you can use this first tab. Or if you want to apply the filters based on 2-3 columns, then you can use the expression option. So here what we can do is we can add on which column you want to restrict that, on which attribute basically. So we want to restrict by year. So where do we have that? Here we have year. And what is the operator? So you have different operators here. You can choose whichever you want. So we want equal to 2004. Okay. So this is going to be our one measure, one restricted measure. So in the same way, we need amounts for 2005 as well. 2005, and measure is going to be same. And then the attribute is also going to be same, but the filter changes. Okay, so the filter is going to be 2005. Click on OK. Then the next one is going to be the last one, amount 2006. Measure remains same, and attribute is also same. Value will be 2006. So now we have got our 3 different restricted measures here. Let's go ahead and activate this. And it's activated successfully. Now let's do the data preview. So if you see here, let's analyze our revenue by shop names. So we have got different shop names here, and then we have got our amount sold, the total revenue. So now this is how it looks. Just sum of everything by shops. But I want to see how these shops are performing over a period of time or over different years. So instead of adding this, if you have these values, see, now we can quickly identify how this shop was performing over a period of time. The shop in Dallas was having a very good, it has very incremental growth. Like it has got some 427k revenue in 2004, then it has become 739, then it has become 803 now. So which means it's constantly growing. And if we need to identify some of the shops that were having some issues in middle, so you can quickly identify by looking at this value. See, this one, the one in Boston, has 238k revenue in 2004, but suddenly it dropped down to 157, and then we have got sudden growth again to 890k revenue. So these are, you can quickly identify like how those shops were performing by time instead of just looking at the sum of the revenue. So this is how we can make use of restricted measures. And the other one I explained about like how we can do different aggregations on our measures. Okay, so to change the aggregations, by default, whenever we apply or whenever we make one column as measure, the by default aggregation is going to be sum. So if you see in the semantics tab, it's going to be by default sum. So if you do want to modify the aggregation type, you can only modify for the columns that are directly coming from a table. Let's say a margin or amount sold or quantity sold. So if you want to change the aggregation type, you can change it here. You can change it to min, max, or count. Let's say now another example is going to be like Here I want to see the revenue. Let's take this out. Okay, so by shop, what is my revenue amount basically, and I want to see like how many products I have sold from each shop. So how can I do that? I have my article ID. Okay, so I've got my article ID here, so which I'm gonna put here, and then make the aggregation type as count. So now I know that I've sold some 7.2k products from Austin shop, and I've got total 2.7 million revenue in entire that shop period. So but when you look at this article count, this is actually all the article count. Like I might have sold article 100 around 50 times, so still it is going to count it as 50. It will not count it as 1. But let's say I want to see how many distinct articles or how many unique articles I have sold from each shop. So how can we identify that? So if you look at the measure aggregation type you have here, the count, this actually will give you the count of all the articles. It will not give you the distinct count. So even we can try that. So let's go here. Let's go to our star join or logical join, and let's create a new calculated column. Okay, and then make it as article count. Okay, and then here I'm going to make this as a big int, then make it as measure. So I don't want a formula because it's going to take a default aggregation as sum. So what I'm going to do is I'll choose this option, calculate before aggregation, and I'll keep the aggregation type as count. And here I'll just add my article ID. Article ID, that's it. So validate, click on OK, and then activate this. So it's activated successfully. Even if you want to verify that, so for Boston we have got 3.3k article IDs. So if the formula whatever we have created, if it's going to calculate the distinct article IDs, then the value should be definitely less than 3.3k. Now let's see how the value is going to be. So let's go and do the data preview. Then shop ID name in the label access, and then amount sold along with our article count. See, we have got the same value, which means it is doing count of all. It's not calculating distinct count. So how can I get that distinct count? So for that, we have got a new function available from SP7, I think, which is, if you right click on calculated columns, the second option is new counter. So if you want to have a distinct count for any column, then you have to go for a new counter rather than creating a calculated column. So here, see, article, I'm going to make this as D underscore count, which is a distinct count, and you can add the column here. So we need 80 time 80 article. What happened to our article ID? Yeah, here it is. So I want distinct count of article IDs. So click on OK. So we've got the new one, and let's go ahead and activate this. So it's active now. Now let's do a data preview. Again, the same condition, shop ID name, Then let's go to our measures here. So we have got article distinct count. Then immediately you can see the Boston has only 82, and then amount sold. So out of 3.2k total article sales count, there are only 82 unique products. So we have only sold 82 unique products of 3.3k sales to get 1.2 million revenue. So to get a distinct count, so we have to use that counter. So this is another useful function where most of the times clients will need, like, how many distinct products I have sold. So most of the times you might get a requirement where you need to calculate distinct count instead of just calculating count. So this is another useful thing you have in analytic view. And the next one we have is the next thing is going to be like, see, whatever the filters you give here, these are all static filters. Look, by default these filters will be applied whenever you execute this modeling object. Most of the times customers won't agree for that. They say, okay, I need pop-up whenever I execute this object so that I can give the values to those filters. So they'll ask for a runtime filters instead of static filters. So whatever we have applied here, those are all called static filters. But how can we put runtime filters in an analytic view? Okay, so now we'll see how we can put those runtime filters. So that actually can be achieved with the help of input parameters here. So using input parameters, you can put runtime filters on analytic view. So to create input parameter, right click on that and say new. Let's say I want to put input parameter on my calendar year. So what you can do is, so give the name for this calendar year, and then there are different parameter types, like you have 4 parameters. So the first one is like, so parameter types in IP, input parameters. First one is direct, like you can enter the value directly. Okay, and the next one is column. So you choose any one of the columns from that analytic view so that they can pick the value list will be populated from the data you have for that particular column. And the next one is derived from a table. So let's say whatever the values you want to give for input are not part of your analytic view. They're actually in a different table. So in such cases, you can make use of this derived from table option. And the last one is static list. So you can define static list so that that particular values will be populated to choose for a user whenever they execute this object. So now let's see how we can create that. So here you have 4 different options, as I said. If you go for the first one, direct, then you can either give a constant. You can either say you can give constant value for that, or you can go for an expression. If you go for an expression, then it's always going to be like whether it is a currency value or unit of measure, those things. But most of the times you will go with constant. And you can also choose whether the input filter is mandatory or not. So if you don't select this as mandatory, even if user doesn't give any value for that, they can still see the entire data. Okay. Then the next option you have is column. So this is where we can choose our requirement. We can fulfill our requirement. Let's say now I selected column here, and then you can go ahead and choose from which column you want to populate those values. So basically I want to give values from my year column, and then you can also give what should be the default value. So basically initially I want to put a 2002 as a default value there, or if you want to write an expression there, you can still write that expression. So what you can do is, instead of just giving 2002, whenever they execute that reporting object, that particular analytic view, I want to populate current year. So how you can calculate current year? You can make use of the functions. Like you have now. Now means it gives current timestamp. And then, but you don't need timestamp, you need only year from that. So what you can do is you can make use of conversion functions. So what you can do is put date for that. Put date of now, and then what we can do is, even in that also, even in the date, so the date format in HANA is going to be YYY hyphen mm hyphen dd. It's going to be like this. So, and when we say now, that is timestamp, like HHMMSS. So what we did is, using the date function, we removed this. Now we have this one. Still we don't need this. We actually need these 4 characters. So what we can do is, for that, so if you do, it's a valid function till here. So for that, what we can do, we can make use of left string. So put a left string there. So we need only 4 characters from left. That will give us the current year. So this is how you can put a complex functions here. Or if you want to just give a simple some static year, you can choose constant option and you can give it. Or if you want to do something stuff like this, you can still do that. Now let's go ahead and add that. Now we can see the new input parameter here, and we can go ahead and validate this. So it's completed. Now let's go ahead and activate. Yeah, completed successfully. So here, why we won't get that filter is because we have a role assigned as modeler, and we will be having full authorization on this particular modeling object. So that's why we don't get that filter usually. But as a business user with minimum authorization, when you execute that modeling object, you will get that pop-up, so that you can enter that value and then you will see the relevant data in the output. So these are the different advanced options we have in Analytic View, which will be useful when you want to apply the complex business transformations or complex business logic in the Analytic View, so that you get a proper data for the reporting tools. So in the next session, we'll see how we can do a currency conversion in Analytic View, which is going to be one of the most frequent requirement you get from the customers. And in the coming sessions, we'll see like how we can build a calculation views as well. Thank you for watching. Have a good day and happy learning.